I'm going to talk about how we use MLIR to test ReRAM cells. Now you might ask, what are ReRAM cells? So ReRAM cells are a new type of electronic device. And the interesting part is, if you apply a high enough voltage in one direction, the resistance value will change in a physical way. So it's non-volatile. And there are then mostly two values that it can have, but there are also multi-value cells now in development. The switch is non-volatile, and the read speeds for those types of memory are comparable to SRAM. But they're not reliable yet. They're not there yet. But now we might ask, why are they useful? So if you put them together in a circuit, which we call a crossbar anomaly for these cases, and we apply a voltage to multiple lines, we get a multiply and accumulate operation for the current that we get out of there. So we use it for ML, because ML is important. But they still don't work. So we designed a PCB to test crossbars because you can get them, but they're just not there yet. And we want to evaluate what influence the imperfection have on neural network accuracy at the end. So we designed a PCB where you can insert your crossbar in the middle, and normally on the left there's also an MCU attached to it, and we have written a Python library that can communicate via serial interface to the PCB here. Now, how we've done that. So the crossbars we normally get are super small and all of that, and they're also for multiply accumulate operations. So we focused on linear.matmul operations, but it's still quite general. It's just that I wanted to try with one thing first. So I tested everything using the transform dialect, and I probably misused it because I use it to create operations in the middle, but it's super convenient to do that. And you can just snippet your matmul to the correct crossbar sizes, and those are the crossbar sizes we normally see, like 4 by 16. So not really useful for transformers or something like that. But there are chips in development that say like, hey, we have 1 megabit, so we get there. Then I have to offload something to the serial interface. I have something that actually a lot of downstream projects have. I have a pass on an interface that just converts my operations to a function call and casts the shapes away. So maybe this is something that I can upstream because a lot of people are implementing something like this. It's super easy. And then I use the Python execution engine from MLIR to call into the serial interface. So I have the Python execution engine that calls into the MLIR file, and when there's a function call, I have this function registered that gets called from MLIR. And what's interesting, that it's even possible. So first of all, this is my simulation. If I'm not using the serial interface, it's just a dictionary. But you can change memory values from Python in place, which is really interesting and can open up a lot of possibilities. If you don't want to write some weird IR to change your values, you can just use NumPy or something else. And that's all. Short talk.